Section 7.1 is on ratios, proportions, and the geometric means. So in this section, we're going to be solving problems by writing and solving proportions. So for this, the first one is the ratio of A to B. And the first one that you see is always going to go on top, and then the second one letter or variable that we see is going to go on the bottom. So one way to write ratios is as a fraction, or you could go ahead and write it as A with a colon to B. So those are two different ways that you can write ratios and the ways that you will see them. A proportion is when we have two ratios that equal to each other, so A over B equals C over D. And that would be proportions, where you have two fractions or ratios set equal. And then we have our means and extremes. So in a proportion, A over B equals C over D. The means are going to be the B and C. And the extremes are going to be A and D. And we use these throughout to solve problems that are given to us in proportions. If you don't have those vocabulary words memorized, that's okay. You'll still be able to do the problems. And then our last one, our geometric mean, that is when we are going to take the cross product or cross multiplying of the proportion, and then we're going to take the square root. So if we were given two numbers, A and B, we would set up our geometric mean with A over X equals X over B. And we need to solve for X, and that's what our geometric mean would be. So if you want, you can cross multiply, and that's when you take the top and the bottom of the opposite fractions, multiply them together, and set them equal. So this one we would take X times X to get X squared, and A times B to get AB. Then we would solve this fraction by this equation by taking the square root of both sides. So the geometric mean is going to be the square root of AB. And we're going to use this and go over some examples at the end of our notes today. To start off with, we are going to start by simplifying some ratios. So you can leave them in this format where we have the colon, or you can go ahead and write them as a fraction. So we've got rid of those, and we're going to simplify these. So you're going to find the greatest common factor or any common factor to simplify these. So in my last time I did this, we started by dividing by 2. And we would end up with 38 over 4. And you notice these are still both even, so we can divide by 2 again. And we would get 19 over 2. And that would be our simplified ratio, because we got as far as possible with the common factors and simplifying it. One thing that you need to know is when you're simplifying these ratios, they have to have the same units. So you'll notice in this problem here, we have feet and inches. So we're going to have to change one of those numbers so that they're in the same unit. You could either change the feet to inches or the inches to feet, whichever works for you. So for this one, I'm going to change the inches to feet. So to go from inches to feet, you're going to divide by 12. So 24 inches is equal to 2 feet. Then I'm going to rewrite my ratio so that we have the same units. Over 2 feet. So if we simplify this, we can divide them both by 2, and we would get 2 feet over 1 foot. Sorry, and I don't know why I got rid of those labels. We're gonna keep those here. Sorry about that. So then our answer would be 2 feet to 1 feet. Our next example, example 2, is you are painting barn doors. You know that the perimeter of the doors is 64 feet, so that's going to be important information. And the ratio of the length to the height is 3 to 5. They want us to find the area of the doors. So first of all, the formula for area is length times width. So we're going to have to figure out what the length times height. We're going to have to figure out what these are. So to help, we're going to start by drawing a door. And this is what we're painting. And the ratio of the length to the height is 3 to 5. So that means for every 3 feet we have over here, we're going to have 5 feet on top. But we don't know how many groups of 3 we have on the bottom or how many groups of 5 we have going up and down. So to help us, we're going to put X with that. And because this is a rectangle, we know the opposite sides are congruent. And now we have enough information to set up an equation with our perimeter. So we're going to add up all of the side lengths and put that equal to the perimeter of 64 feet. Then we can solve for X. So we're going to combine all of our like terms, and that will give us 16x equals 64. And then we need to divide by 16 to get x by itself. And let me pull up my calculator really quick, just to make sure I get the right answer. So we're going to have 64 divided by 16, and that equals 4. So now we know what x equals. We still need to figure out what the length and the width is. So we're just going to take that x and we're going to plug it in. So we're going to take 3 times 4 to get our length, and that's going to be 12. And then we're going to take 5 times 4 to get our width, which is 20. So we're going to have 12 times 20, and that will help us figure out what our area is. So for this, our area is going to be equal to 240 feet squared. Okay. So that is an example where we use the ratios to help us figure out the area. Our next one is the measure of angles in triangle BCD. So I'm just going to start by drawing this. BCD are in the extended ratio of 2, 3, 4. So this goes BCD. They want us to find the measures of the angles. So to do that, we're going to take these ratios, but we're going to add x's with them. So we're going to have 2x, 3x, and 4x. And we can go ahead and put those in our triangle. So we have that visual. And if you remember back to any of our triangle chapters, the 3 angles inside of a triangle have a sum of 180. So to solve for x, we're just going to take all of these angles, add them together, and put it equal to 180. Then we're able to solve for x. So we combine all of our like terms, and that will give us 4, 5, 6, 7, 8, 9. X equals 180. Then we'll divide both sides by 9. And we will be left with x equals 20. And we want to make sure we're answering the question they give us. So they want us to find the measures of the angles. So then we're going to take that and plug it into all of the expressions we have. So we know the measure of angle B equals 2x. So that's going to be 2 times 20, which equals 40. the measure of angle C equals 3x. So we're going to set that up by 3 times 20, which would be 60. And the measure of angle D equals 4x, which is 4 times 20, and that will equal 80. Don't forget your degrees when you are labeling these, and then that will be our final answer. Just going to get rid of the calculator so this is a little bit bigger. All right. Our next examples, these are on solving proportions. So again, we're going to use cross multiplication. So when you cross multiply, you're going to take the opposite numerator and denominator and multiply those together. So for this one, we're going to take 4 times x, which is 4x, and then we're going to set that equal to 3 times 16, which is going to be 48. Then, once you have just a normal equation without fractions, you can go ahead and solve for x. So this one we divided by 4, and we would get x equals 12. Our next one is very similar, except this one we have 2 parts, or 2 terms, in the bottom of one of our fractions. So when you have 2 terms, you are always going to put parentheses around them before you multiply. So then we would have 2 times x plus 1, and then that will be set equal to 3 times x, which is just 3x. The reason we need the parentheses is because we now are going to distribute this and multiply it by both terms that were inside the parentheses. So that's going to give us 2x plus 2. That's still equal to 3x. Then once we get here, we can go ahead and get all of our x's on the same side of the equation, and we will get x equals 2. Our last thing we're going to go over is geometric mean. And the geometric mean of 2 positive numbers, a and b, is the positive number x that satisfies a over x equals x over b. So if we are using cross multiplication to solve this, x times x is x squared, and then a times b is just ab. And then if we were to solve this equation like we went over earlier, we would take the square root of both sides, and that is where we get x equals the square root of ab. So this equation you are going to want to remember so that you can use it to solve problems when you're asked to find the geometric mean. Like our next example, we're going to find the geometric mean of 16 and 48. So when assigning a and b, you can choose either or to be a and b. And we're going to use the equation that they gave us. So for this one, we're going to have x equals the square root of 16 times 48. And again, we can use our calculator for that. Now that I got rid of mine, got to bring it back. So we have 16 times 48, and that's going to equal 768. And then when you find the square root in your calculator, so for this one, we're going to take the square root of, I don't know where that came from, 768. We're going to go to 4 decimal points. So this one's going to be 27.7128. So 27.7128. So you're going to round these to 4 decimal places. When necessary. If you don't need to round to 4 decimal places, if the whole number is on your screen, you can just write that down. That is all of our notes for 7.1. The homework is posted, and if you have any questions, just let me know. Don't forget to check your answers.
To the main office, please. Sound hi, Sunny, to the main office.
Sorry about that. Don't forget to check your answers with the key on school.